Today we're going to talk about calculating slope. So we're going to start by calculating slope from a graph. So we talked last week about slope. Slope is kind of the roadmap or the directions of how you get from one point to the next in your line. So it tells us how steep our line is, what angle it's on, and we did discuss as well how you find slope. You can either do rise over run. So we do how far up or down it's going divided by how far it goes from side to side. Or a little more formal, it is delta y, or the change in y, divided by delta x, the change in x. So our y values are up and down values, so it tells me how far up or down we've gone. And then delta x, that's our side to side numbers, so it tells me how far left or right we've gone. So we're going to start with an example. It says calculate the slope of each of the following. And there are three graphs. So we're going to start with our first one. I guess I didn't label this as graph A. So when you are trying to find the slope, the easiest place to start is actually the y-intercept. And if your y-intercept isn't working out, then I would try to start at a different point. But on this graph, I have a nice y-intercept right here at 2. And when we're graphing lines, which we learned how to do last week, we started at the y-intercept and then we followed our slope to get to the next point. So what I'm going to do is follow the line and see if I can find the next clean point on my graph. So I'm looking for a point that's on a corner of where two grid lines meet, so that it's something that I can actually read off the value of. So if I follow my line, I notice at 1, that's partway through a line. 2 is not good, 3 is not good. Now, depending on how small your graph is, sometimes it gets a little tricky to tell. And what if I thought that it was here at 4? Now, I can see, because my graph is a little bit bigger, that there's still a little bit of a gap there. But sometimes on the one, if you printed it off the website, off our Google Classroom, you might have found that it does kind of look like it's at 4. So it's a good idea, if you think it's at 4, that means we would have gone up 1 over 4. Then I would try going up 1 and over 4 again to see, am I still on the line? And if you're not still on the line, that's not the right slope. So I can see from my line, because my grid's a little bit bigger, that it's definitely not at 4, but I am pretty sure that it's here at 5. Now the problem is that your graph only goes up to 8. So if I went up 1 and then over 5, and then I tried to go up 1 and over 5, I actually can't see those points because the graph only goes to 8. But I could try going backwards. If I go down 1 and over 5, I am definitely still on that line. So I'm feeling reasonably confident that we are going up 1 and over 5. Which means my change in y, the up and down part, is 1, and the change in x, the side to side part, is 5. So my slope here would be delta y, 1, over delta x, which is 5. So I would get 1 over 5. Now, just in case you didn't go forwards, what if you went backwards? So what if instead of going forwards on your line, you had gone backwards from this point to this point? Well, if I try doing that, to get from here to here, I went down 1, so I subtracted 1, and I went backwards 5, so I subtracted 5. So if I try to do the slope using those numbers, I would get that the slope is delta y, or the change in y, negative 1, divided by negative 5. There's my delta x. Now, a negative divided by a negative makes a positive. So this would still just be 1, positive 1 over 5. So if you go forwards or if you go backwards, as long as you pay attention to signs, that going up is positive, going down is negative, going here to the right is positives, right? We're getting into larger numbers. Going this way is into the negatives. You will still get the same slope, whether you go forwards or backwards. Okay, so if you join me in the next video, we will take a look at the other examples.